Hello everyone, my name is Oluwasegun. I'm one of the group 9 members. I have my other team member, Roshan Tapa, and today is the 21st of February, and I'm presenting this project to us right from the start so far. So here are the team members. We have Roshan Tapa, who's the team leader and the developer, and Oluwasegun Laleya as the data analyst. Here's a table of content. We have the project summary, the data set, the data cleaning and analysis, then to the current recommendation, the internal communication plan, the milestone review, project cost. So far, I'm just going to be taking you through what we've been doing on this project so far. This is the project summary, and this is talking about basically what the project is all about and what we're trying to achieve in this project. Now to the data set. We used got the data set from Kaggle, and it was a bit challenging because at first we were working with Steve Kuruvilla, and right now he's no longer in the group. So the data set we had initially, we had to change it so that it's something that I and Roshan can work with. So we got this data set from Kaggle, and it has about 8 variables, which are the area, the cancer type, the year, the sex, the race, the mortality type, and the type, and the age-adjusted rates, the case count, and the population. Here we extracted the data set. My team member, Roshan, will be explaining more on this aspect, the Jupyter notebook and everything, how it was done here. Same with the summary and feature engineering. And the data, here is the data cleaning, and okay, here on to the data cleaning. It's going to be explained by Roshan, like I said before, so I'll just move over to the count plot. Showing us here is just trying to reflect the area and the count, which shows that California has the highest count of cases of cancer type in this area. California is the area with the highest count of cases so far. Onto the bivariate analysis. So we did a bivariate analysis for all the variables, and as you can see here, this is a combination of all we did with the bivariate analysis. Here's to we plotted area versus population, and using the Power BI, we discovered that out of all the areas we have on the data set, California is the area with the highest population generally, and is the area with the highest case count. We plotted sex versus race, sex versus case count. Here in the data set, there are only 2 categories of sex, which are the male and the female, and we wanted to know which of the sex has the highest case count, if it's the men or the women that has generally the highest cancer type. To the multivariate analysis, Roshan will be able to explain better what we have on the multivariate analysis. Okay, to the next phase. This is just trying to let us know what we have to do in the next phase of this project, and We faced a lot of challenges. One was the use of data variables for the analysis, and the other one was creating visualizations to extract meaningful insight. Of course, so these are the strategy we used to achieve that and to overcome the challenges we faced so far during the project. Now to the internal communication plan and how we've been communicating so far. This is the overview of the internal communication plan. The MRP high level tasks. So far on our SharePoint, this is letting us know how we've been communicating and what we've been doing so far in this project. Okay, so we started this project in last semester, and this is an overview of the milestone where we are right now. So we are still in the requirement phase, and by next month we'll get to the design phase. In April we'll release the project and close out with the project and be done with the project. So for the project cost, this is an overview and a visualization of what the project cost is looking like. From here we can see that the design, the development phase, and the requirement, everything, the sum of the budget cost is actually more. So at the end of the day, this is what we realized. I'll hand over to my colleague Roshan Tapa to take us through the Jupyter Notebook and every other coding aspect of this project. Once again, my name is Oluwasegun Olale, and I hope that it's been an interesting one. And thank you very much for listening.
Hello everyone, it's me Roshan Thapa, team leader and developer for Oncology Diagnostic Insights. Firstly, I want to thank Oluwasegun for giving such a nice presentation on explaining what we learned so far, what we achieved, and what our recommendation or next plan for this project are. So I'll be showing you a code implementation of all the visualization that we have done so far. So we have used Jupyter Notebook as our IDE. So firstly, we have imported all the necessary libraries such as pandas, numpy, seaborn to create a visualization, attractive visualization. Reading the dataset, we have saved our dataset in our local machine. So reading the dataset or loading the dataset into the Jupyter IDE. So after dataset, you can see that the first five dataset, the last five dataset, uh, we can see the missing values for some of our columns that are not presented. So we need data cleaning. Firstly, we're checking the summary of the dataset. Here we find out that the data type of all the variables are object, but it is not true. We know that the data type of age, adjusted rate, case count, and population are integer. So let's get into data cleaning. Firstly, we have done feature engineering, splitting start year from the year, then replacing data not represented with the NaN value, and dropping rows with missing values. Next up, we are converting the columns that are of integer type to their data type, that is age, adjusted rate, case count, and population. So after this data cleaning, when we check this summary, we see that the data type of numerical value has changed and we have new column start here. So when we check, we see the changes start here, cancel the tail, the missing values are removed. So checking some of the unique values, some of the calculation unique values and unique. to check the unique values of each column, null values to check the null values, describe the summary of the numerical values calculating count, mean, median, standard deviation. Statistical summary of categorical variable is also calculated, but it shows the non value because there are no numerical values. Next up is determining categorical variable and numerical variable. In our data set, we have categorical variable as area, cancer type, year, sex, race type, data type object. Here is shown as object data type because we have range from 2016 to 20. Numerical data type age adjusted rate, case count, population, and start year 2016. So next up is some calculating some skewness. So age adjusted rate skewness 0.27. It is positive but near to zero, certainly more than zero. So it is symmetrical. Case count has very positive skewness, so we can see that it is the tail to the right and there are so many outliers. We have to fix it for further analysis. Population also positive skew. Outliers start here. It's only 1 year, so that's fine. So we're moving up to the visualization of some categorical variable, count of area, case count, count of cancer type. So for this visualization, we can see here area, cancer type, year, sex, race, type. So it is also bar chart with its frequency. It is very useful for further analysis. Box plot, same thing. Box plot for all the variable accumulative type. Calculating frequency of each area. Here we can see the area. It is unclear. So we want to show that the frequency of area. Here we can conclude that California has the highest frequency of 9. And these are the top 5 areas. Such a nice visualization. Bivariate analysis to find out the relation between two variables, either categorical or numerical. Area versus case count. Which area has the most case count? We can conclude that Ohio has the case count near to 7,000. Area versus population. Which area has the more population? California has the more population, 2.5 million, more than that. Cancer type and case count. Which cancer type has more case count? Colon and rectum has case count over 5,000. Uh, Cancer type versus age adjusted rate. Which cancer type has more age adjusted rate? Colon and rectum for sure. Race versus case count. Which race has more case count? White non-Hispanic has case count more than 3,500. Race versus age adjusted rate. Sex versus case count. Which sex has more case count? Here we can see that the female has more case count, more than 3,500. This is just some uh, relation of some variables that we created while practicing. Heat map, such a nice graph to show the correlation between the numerical variable. Age adjusted rate, age adjusted rate, case count. So yeah, there are all the uh, analysis that we have done, univariate analysis, cleaning the data set, and multivariate and bivariate analysis up to now. Further, we are looking to creating a BI dashboard to represent all the analysis that we have done so far. Thank you.